Which planet is easier to terraform, Mars or Venus? Mars and Venus are Earth's two twins, or not. Venus is a hell where sulfuric acid rains and temperatures melt lead. In contrast, Mars is a cold desert where temperatures can drop to minus 200 degrees Fahrenheit or minus 129 degrees Celsius. Both worlds are extremely opposite, but if humanity wanted to move to either of the two in the future, which would be easier to terraform? Are both planets equally optimal for becoming green and blue worlds like Earth? Let's find out. Terraforming. This is a hypothetical process aimed at deliberately modifying the atmosphere, temperature, topography, or ecology of a planet or natural satellite to resemble the Earth's environment and make it suitable to host living beings. The term terraforming itself was first used in 1982 when planetologist Christopher McKay wrote Terraforming Mars, an article for the British Interplanetary Society in which he proposed a method for heating the atmosphere of Mars. Venus's atmosphere is so dense that its pressure would crush us, not to mention the temperature at the surface is around 500 degrees Celsius. Mars, by contrast, is an icy planet that lost most of its atmosphere, lacking oxygen to breathe. None of our neighbors within the solar system are incredibly hospitable to living things. However, on the last mission to Mars, the Perseverance rover managed to convert carbon dioxide, CO2, from the Martian atmosphere into a small amount of oxygen for an astronaut to breathe. This could be the first step, somewhat modest, but hope for future terraforming of the red planet. For his part, the famous astronomer and science popularizer Carl Sagan, known for the television series Cosmos, proposed the application of planetary engineering on Venus to make it habitable in an article published in the journal Science in 1961. They planned to seed the atmosphere of the fiery planet with algae, which would be responsible for quickly consuming CO2 from the atmosphere, thus reducing the planet's greenhouse effect and making it friendlier to other forms of life. It seems that both Mars and Venus are excellent candidates to be terraformed, but what process would we use to achieve this? Terraform Venus. Let's start with the closest to the Sun. Venus is a very hostile planet with living beings. It has a weighty atmosphere, it rains sulfuric acid, it has scorching temperatures, but even so, several ways have been proposed to make it a more friendly place with life. The experts who have spoken about it agree on the need to make 4 substantial changes on the planet to carry out the terraforming process, all of them closely related. The first is the most obvious. Reduce the surface temperature of Venus, which is estimated at 464 degrees Celsius. Second, transform or remove most of its atmosphere, composed mainly of carbon dioxide and sulfur dioxide. Third, add or extract the oxygen needed to breathe from the planet. Fourth, altering the low rotation speed of Venus to reduce the day-night cycle. Currently, 1 day on Venus equals 243.0223 Earth days, which is a minor problem, but a problem anyway. Number 1. Cool the planet. One of the main factors contributing to Venus's elevated temperature is its proximity to the Sun. It receives about twice as much sunlight as Earth, sitting right at the inner edge of the solar system's habitable zone. Consequently, most of the alternatives proposed for hypothetical Venusian terraforming go through a reduction of the solar radiation that the planet receives to maintain the conditions of habitability. Sunscreens could be used to reduce the total insolation received by Venus, cooling its surface enough to undertake the rest of the changes in its environment successfully. A screen at the L1 Sun-Venus Lagrange point would also block the solar wind, eliminating the problem of radiation exposure on Venus. Building a sizable solar screen is a daunting task. The size of the sunscreens in the L1 point of Venus would have to be 4 times greater than the planet's diameter, which would require unknown planetary engineering and is still non-existent. In addition, it would be highly complicated to balance a thin sunscreen between Venus and the Sun, since the pressure of the incoming radiation would turn it into a gigantic solar sail. If the screen were brought to the L1 point, the pressure would add force to the solar side, and moving it closer to the Sun would be necessary. The scientist and writer Paul Birch proposed using a series of contiguous mirrors near the L1 point between Venus and the Sun. The sunscreens would not be perpendicular to the sun's rays. They would be located at an angle of 30 degrees that reflected the light from one panel to another, negating the pressure of the photons. At present, solar space screens and solar sails in general are still in a primitive state of development, since the enormous size required would require an amount of material that exceeds by several orders of magnitude any other object launched into space or built directly into it. Cooling could also be carried out by placing reflectors in the atmosphere or on the surface. It has been suggested that reflector balloons float in the upper atmosphere to create shadows can be suggested, although their number and size would necessarily have to be significant. Gregory A. Landis has proposed as an alternative that a similar effect could be achieved with the construction of floating cities that form a reflective shield around the planet while processing the atmosphere to adapt it to acceptable conditions for humans. In this way, the theory of the solar shield would be combined with the atmosphere's processing, achieving Venus's terraforming by applying a scalable technology that would immediately provide a habitable space on Venus. Another method to reduce the planet's temperature could be to use transparent or reflective materials on the surface, increasing the albedo. Again, it would be necessary to employ large quantities of these materials and would have to be done after its atmospheric pressure has decreased, since dense layers of clouds entirely envelop Venus. Number 2. Remove the CO2 from the atmosphere. If any of the techniques mentioned above managed to reduce the planet's temperature, the following phases would be more manageable. In his 1961 paper for Science magazine, Carl Sagan proposed seeding Venus's atmosphere with algae that would absorb carbon dioxide and reduce the greenhouse effect, fixing CO2 in organic forms and releasing O2 in the process. In this way, it would reduce greenhouse gases and, at the same time, fill the entire planet with oxygen. However, this paper was produced years before the Venera 4 probe landed on the surface of Venus and managed to transmit data on its atmospheric conditions, demonstrating that its density was too high for Sagan's proposal to be successful. Although algae could thrive in the harsh conditions of their upper atmosphere, it is estimated that carbon fixed in organic form would likely be released as CO2 as soon as it fell into the hot lower regions. The production of organic molecules from carbon dioxide requires an additional supply of hydrogen, which on Earth is taken from its abundant water supply, but which on Venus is almost non-existent. For this reason, eliminating CO2 and in turn filling the planet with oxygen requires a considerable contribution of hydrogen. For now, there are different proposals such as taking hydrogen from the Moon to Venus or deflecting a comet and making it collide with Venus on purpose. However, none of these proposals fits modern technology. All require advanced space mining, which is still in a very primitive stage. Having said all this, it is more than clear that terraforming Venus is not easy. But what about Mars? Terraforming of Mars. Turning the red planet into a home for humanity would not be an easy task either. Experts have pointed out that the main objectives for terraforming Mars would be: first, increase the temperature of the planet; second, endow the planet with a magnetic field; third, fill the planet with oxygen; fourth, get water, either by carrying it from the Earth or extracting it from the planet itself. Increase the temperature of Mars. Unlike how complicated it is to lower the temperature of Venus, increasing the temperature of Mars would be simple in comparison. All we would have to do is fill the atmosphere with greenhouse gases. Today it is known that in the polar caps of the red planet, there are significant accumulations of frozen CO2, ammonia, and methane. Thus, all we would have to do is melt them so that they are released into the atmosphere, either irradiating them with sunlight or even with nuclear bombs. A somewhat controversial proposal that scientists do not rule out. So that the atmosphere does not escape from the planet, we would also have to provide it with a magnetic field. On Earth, the magnetic field is generated thanks to the rotation of the core, but on Mars, this does not happen. So we would have to provide an artificial magnetic field. During the 2050 Science Planetary Workshop in late February of 2017, NASA scientist Jim Green proposed to launch a magnetic shield between the planet and the Sun to protect it from high-energy solar particles located at a Lagrange L1 point, a relatively stable point between Mars and the Sun. This artificial shield would allow the planet to restore its atmosphere, rapidly improving its habitability. Simulations indicate the planet could achieve half of Earth's atmospheric pressure in a matter of years, not centuries or millennia. Without solar winds affecting the planet, the carbon dioxide frozen in the ice sheets of each pole would begin to sublimate and warm the equator. Thanks to this, the ice sheets would begin to melt to form an ocean little by little. Currently, this is the most accepted proposal since it can be carried out with modern technology and not with unknown engineering, as in the case of Venus. Once we raise the temperature of Mars and endow it with its magnetic field, we will move on to the last stage of filling it with oxygen to breathe and water to support life. The most important way to create an atmosphere on Mars is by importing water and obtaining it from the ice of asteroids, the moons of Jupiter or Saturn. Adding water and heat to the Martian environment is vital in making this cold, dry planet suitable for hosting humans in the future. An essential source of water nearby is the dwarf planet Ceres, which according to studies occupies between 25 and 33% of the asteroid belt. The mass of Ceres is approximately 9.43 times 1020 kilograms. Estimates of how much water this dwarf planet may have varied considerably, but at least 20% is a reasonable typical amount. In addition, it is thought that much of this water is found at the surface or near the surface level of the planetoid. Current estimates of the amount of water on Ceres indicate that the water that could be extracted from this dwarf planet would be equivalent to 0.03% of the total mass of Mars, more than enough. The transport of a significant amount of this water, or in general from any of the icy moons, would be an engineering challenge, considering that we are not yet able to carry considerable loads to nearby worlds such as the Moon, let alone distant bodies such as Ceres or the moons of Jupiter and Saturn. However, if somehow it is possible to bring water from icy bodies to Mars, the terraforming of the red planet would be a reality. All that said, which planet would be easier to terraform? The undisputed winner is Mars. The red planet has much friendlier conditions with living beings than Venus. In addition to the length of days on Mars, they are very similar to those of Earth, so we would not have to change its rotation period as in the case that we wanted to terraform Venus. While to terraform Mars, we must build an artificial magnetic field that's much easier than building solar sails larger than Earth to cool Venus. Also, transporting water from icy bodies to Mars seems more straightforward than carrying them to Venus, which is much farther from the nearest water reservoirs like the icy moons of gaseous planets. For this and much more, we believe terraforming Mars would be easier than terraforming Venus. What do you think? Do you think terraforming Venus is more accessible, or is it simply challenging to terraform both planets? Let us know your opinion in the comments.